Start recording. Perfect. All right, let me share my screen real quickly with you guys. All right. Can you guys see that okay? All righty. So, as always, welcome to the Zoom Rock Room. Like I said, you guys are stuck with me this evening. For those of you who don't know me or haven't been in for a while, just a reminder, my name is Mel, and if you need anything, you can always type it in the chat. Unfortunately, I don't know what episode we are of the Zoom Rock Room, but we are well on our way into those higher numbers. So let's get started. As always, we're sponsored by Lair Architecture in Lake Havasu City in Arizona. Their trademark there is designing for the future. We always have that email provided. So if you would like to say hi or get any architecture advice, feel free to reach out to them. They are more than happy to help. Okay. We also have retro rocks. This has been new in our intro, but they carry fossils, minerals, natural gemstone, jewelry, clothing, and a bunch of other miscellaneous items. They are located on Columbia Avenue in Lancaster, Pennsylvania. So if you're ever out that way, you cross the river and you're looking for a little pit stop along your way, you can always stop in and say hi to them. Like I said, they have a collection of all kinds of miscellaneous fun treasures in there. The Dirtman Report, as always. We always like to highlight Andrew on all of the videos that he records and publishes to various online platforms, including Facebook, Instagram, TikTok, and of course, YouTube. They proudly support the Zoom Rock Room. Their catchphrase is bringing the geology to you. If you are ever in need of looking back on some of their previous episodes, feel free to look it up on YouTube. They are always very funny, very educational, and very helpful to the fellow or local geologists. Moving right along to Buttonwood Nature Center, home of the Institute in Waynesboro. Educate, inspire, and unite. I don't have any dates on their new nature center. I know Jeri would, but feel free if you're ever out that way to visit Buttonwood Nature Center as they are building their new home. They're getting it nice and structurally sound. In addition, like them on Facebook. You can find them on online platforms, like I said, including Facebook. They'll have a bunch of updated reminders and news on that page. You can always become a member as well of the Buttonwood Nature Center, home of the Institute. You can always join them on their website to help support their mission. All right, so this fall, excuse me, this 2024 Fall Festival is happening on, this is new to the intro, this is happening Saturday, October 19th. From 12 o'clock to 4 p.m. It looks like this is happening also in Waynesboro, if you're out that way. Looks like a wholesome family event, full of, looks like some live music, animal rides, kids zones, family fun, games, and a bunch of different themed activities. So fall is one of my favorite seasons. Hopefully it's one of yours. You can always go out to Buttonwood Nature Center and join them for this fall festival. Redline Telescopes with Wade Crow. You can give them a call or you can email them using that number and email listed below. Please, they like to schedule a time for you to come in to view, touch, and demonstrate any of the telescopes that they have in stock. They are located locally in Redline, Pennsylvania. They help customers all over from York, Lancaster, Harrisburg, and the surrounding areas. So if you're looking for a new telescope for your home, or I know, believe it or not, the holidays are right around the corner, feel free to contact them. They would be happy to help you with your search. All right, Rockin' in the Alleghenies in Johnstown. This symposium and mineral and fossil and gem show is an annual event that is happening let's see, on Saturday, 8:30 to 6. The symposium is for the mineral collecting enthusiast. There is a fee to enter, but students are free. It is happening Friday evening on November 8th. There's a meet and greet. And then on Saturday, the 9th, is the hybrid symposium. That can be online and in person. So feel free to take a look at the following information. I know there's a lot on this page, and I guarantee we will be talking about it more and more as the symposium comes closer here in November. The schedule, here's our upcoming schedule. Next time we meet, it will already be October. We are going to be playing a little nature trivia game with some fun prizes that Jeri will have prepared for everybody. This will kind of even the playing field a little bit for those who are really, really into geology. Maybe we can get into more of just the natural sciences so that everyone can have maybe a broader view on some of our different categories in the natural sciences. October 15th, In Search of the Juniatus with Paul. That's going to be happening mid-November or October, excuse me. That sounds very interesting. And then so on into November, on November 5th, and November 19th, we have two programs coming up. And then in December, we don't have any program titles yet. They are still pending on the theme of those episodes. So if you have any ideas, feel free to contact Jeri as always. He would love to hear your ideas. All right. Nova in the Northern Crown. There's still no new news on this, excuse me. Many of you will probably be more familiar with this than I am. However, we are adding it into our intro this week. And last but not least, Jeri's new website has been launched. It is at www.jonesgeo.us. You may subscribe today. And if not subscribed, you can at least go to that website and check out some of the new pages he has listed and some of the information that is displayed on that site. So go check that out if you haven't already. Alrighty, folks. Well, that is the intro for this evening. I'm going to stop sharing my screen and I am going to hand it over to our guest speaker tonight so that she can introduce herself. And if she would has anything PowerPoint wise, she may also share her screen, but I will let her introduce herself to you guys first.
So Melanie, can I share the screen? It looks like that.
Yes, you may, whenever you are ready.
Let's see here. It says host disabled participant screen sharing.
Oh, let's see here. All right, how about now?
Yeah, yes, I can now.
Perfect.
All right. Let's see here. So can everybody see my screen?
Yep, looks good.
All right, okay. All right, well, thank you, Melanie. Good evening, folks. I'm Jennifer Pomeroy. I teach geography at York College of Pennsylvania. Mostly I teach physical geography at the introductory level. I also teach geographic information systems, a couple of classes on that. I also teach land use and sustainability on a regular basis. Often people at your college call me by map lady, so I do a lot of map making, if that's easier for you to know who I am. Well, thank you for the invitation by Jeri Jones. Jeri and I have been good friends for many years. I think ever since I joined York College in 2015, he has been helping me to do a whole bunch of field trips. So we've been to all over in different county parks, some other places as well. So hopefully I will not bore everybody up tonight and could give you some fun and interesting stuff about map making. All right, so without further ado, and I'm going to spend the next 30 minutes to talk about the history of maps. Here is the outline, what I want to talk about tonight: introduction, history of maps, use of maps, new technologies for map making, and lastly would be conclusion. So maps have been around much longer than photographies. Maps have helped humans to do navigation, communication, and also establishment of knowledge on the world geography. Throughout the human history, maps are central. So is map making. Map making in my field is known as a cartography. So cartographers have been changing the techniques, how we make maps, evolving along with advances in knowledge, technology, and also the shift of the world views. So what are maps anyway? So here is a question to everybody. Maybe someone would not mind to share what you think maps are. Do I get some volunteers? Oh, Larry, go ahead.
I guess it's a way of representing where things are located in the world on a flat surface, if you will.
All right, very good, very good. Anyone else would like to share what you think maps are? Larry just made a very good point, especially about location and the surface, right? So those are really important words in cartography. I do have a couple of explanations on what maps are. Maps are tools for us finding our way around. Maps are abstraction of a reality. So as a map maker, I have to make a decision what I want to show on my map. Do I want to keep a topography at the expense of other geographic features? Maybe I only want to show demographics, but I don't want to show any other physical environments. So it's actually kind of like a decision making process there. So to some degree, maps can be misleading. They can miscommunicate a lot of things. I think you guys might be interested in this map. This is the 1979 Michigan Highway map, which is made by an unknown map maker. The interesting thing about this map is, in addition to interstate highways, state freeways, so on and so forth, all of those roads in Michigan, the map maker inserted two fictional towns. One is this a BOSU. The other one is this one here, Goblo. So basically, the map maker intentionally inserted these two fictional towns to express his support for the University of Michigan football team. During that time, because the map was made in 1979, so 80s, 70s, even early 90s, a lot of maps are printed on paper. So with this kind of intentional error, it is to protect the copyright. So if someone duplicates, and then we would know, okay, that's the fake one, and this sort of violated copyright. On this slide, there are two maps. They show exact same information. They both are accurate in terms of a display of information. However, the map on the left is for engineering department. So you see a slightly different representation. The map on the right is for railway or railroad riders. Although the same kind of locations, but they are represented slightly different. So different map uses kind of a dictate how we represent real world features on the map. I don't have a lot of text slides. This is the only one, but I wanted to put over here to give you kind of a chronological context as we are going to look through a whole bunch of maps. Now, earlier maps were dated back to ancient times. We're talking about 23 BCE. Some oldest known maps were made by Babylonians. They carved their maps on the clay tablets. Egyptians made a lot of maps. As far as Greeks, they made a huge contribution for the field of geography. So they're kind of, created a field of geography. So is scientific cartography. Ptolemy wrote this famous book, which is Geographia. So he's considered as the pioneer of kind of a cartography. Moving into medieval time, medieval people made a lot of TO maps. They're simple. They use letter T and also simple ovals representing world geography. We're going to look at some examples. So TO maps during medieval time are largely for sort of a Eurocentric point of view. So they reflect a Christian worldview rather than geographic accuracy. Now moving into the age of exploration, maps making were improved significantly. We see a lot of cartographic advancements. For example, the creation of a Mercator map projection, a whole bunch of other map projections. These maps are made for geographic accuracy, not just for location, but also some other interesting things occurring during that time worldwide. Now, in return, a lot of explorers during age of exploration required to use accurate maps when they go out travel with the discovery of a new world. They brought back a lot of knowledge about other places. And so they kind of fill back into a map making process. So we see that kind of a reciprocal kind of improvement.
I don't know. Guess who called me while I was walking around?
Oh. All right. Fast forwarding to modern era, we're looking at the 19th century and the 20th century. We see a mushroom of a development of topographic maps. You might be familiar with topo maps. So they cover 7.5 degrees. That's a longitude. So very small geographic area, but with a lot of details. You use a topo map for hiking, for navigation, whole bunch of other purposes. And these topo maps made by National Mapping Agency, for example, U.S. Geological Survey in the United States. During that time, other countries also established a lot of national mapping agencies. For example, Ordnance Survey in UK, Cadastre in Netherlands, and the Geospatial Information Authorities of Japan. The most interesting thing about the modern era map making is the thematic maps. So thematic map means we create a map for a specialized usage. For example, we have a weather map for almost a real-time weather forecasting. So we use those kind of information to plan our daily activities. We also created thematic maps for political reasons. Maybe, for example, electoral college. That's considered as another type of thematic map. Economic maps are created. We see land use, land cover change maps, fire maps, COVID maps. If you recall, the beginning of COVID, we had a dashboard, which is type of internet GIS mapping, showing where hotspots are in terms of distribution of infectious disease. So overall, during the modern era, thematic maps play very important role because they actually simplify the complexity of our real world. They visualize data. They help data-driven decision-making process, greatly enhance our understanding of environmental and social dynamics. So basically, we're going to look at a whole bunch of maps encompassing each of the historical period I have on this text slide. So what you're seeing here is the Babylonian map of the world written in Akkadian dated 500 BC. This is the blown up of it. It's rather simple. We see T in the middle representing Babylon. You also see O on the side representing ocean. So geographically, it covers very small area. Other than locality, we don't see a lot of geographic features represented here. There are just two small cities here, islands on the peripheral of this map. This is considered as a milestone map made by Ptolemy in his famous book, which is Geographia. We can see the details of a map increased significantly. We do see a sophisticatedly designed system of a latitude and longitude. So latitudes are these horizontal lines. Right in the middle, that's the equator separating the globe into northern hemisphere and the southern hemisphere. That system of a latitude and longitude really lays the foundation of a future mapping. The other interesting thing about this Ptolemy's Geographia is the location. As Larry pointed out earlier, this map plotted 10,000 locations, encompassing places in Britain, Europe, Asia, and North America. So a very remarkable map. During the medieval time, TO maps are commonly made, sort of assembling what we saw earlier map of. So you see T and O represented on this map. The interesting thing about this particular map is this word Orients. So basically, east is at the top. We often think north is on the top, but this is not the case. Whether north is at the top or not is sort of arbitrary. In the earlier time, we really do not see that up as the north. And also we see this map is centered by Jerusalem. You see three continents. Asia is on the top. You see Europe to the left and Africa to the right, right? Similarly, this is a ideal reconstruction of a medieval world map from a Myers Conversations lexicon. And similarly, we see this paradisus. So that indicates east is at the top. The other thing on this map that's interesting is this idea of Earth is spherical. Earliest the time we thought Earth is just around, actually not quite. We see sort of a different representation, which actually takes us all the way to today's mapping. We generally portray the Earth as one system that is in a sphere. Now we're in 12th century, 1154. This is a famous work in geography and also cartography, Tabular Rogeriana by cartographer Al-Idrisi. Idrisi is a Muslim scholar. If you have a little bit background about the historical development, so during this time, Europe was in its dark ages, right? So often Muslim scholars made some leading accomplishments in math and science. So is map making, comparable, sophisticated as the world map in Ptolemy's map. In some degree, they're actually probably even better because more locations are represented. Going back to the point that Larry made, location, location, location. So a lot of earlier maps focus on representing where things are, where a place is located on Earth's surface. This is considered the finest late medieval world map, which is from Moreau's world map. It took 9 years to create this map. So from 1450 to 1459, really shows a sophisticated understanding of the world. This map is made by interviewing a lot of travelers who went to different places, talk to people about trade routes, and also based on some earlier maps. Like a lot, almost, and like too much to be easily discerned. Now we're back into about the 15th century here. This map shows those journeys Christopher Columbus made in the middle of the 15th century, actually the end of the 15th century. These lines here representing all of those journeys he made. We see continents on the sides, that's Atlantic Ocean, Caribbeans on the side here. Pretty accurate in terms of a geographic representation, not only location, but also sophisticated coastlines, right? So we see a lot of zigzag lines quite portray about the coastlines, especially for North America here. During this time, a lot of the maps similar to these Christopher Columbus maps, they are more of a Western Hemisphere centered. They don't show, I mean, they still show other parts of the world, but generally speaking, it's a little bit wider in terms of geographic extent. Let's see here. And also we see latitudes, longitudes are noted on the sides. When we talk about the Columbus journey maps, we have to talk about map projection. So map projection is a way how map makers to intentionally preserve certain spatial properties, but certain properties are not being preserved. They have to be distorted. So to some degree, we always say all maps tell lie. So they preserve maybe direction at the cost of shape. Maybe they preserve the size to the truest possible, but on the other hand, angles are getting distorted. So that's what the map projection is really about. So what we're seeing here is a Mercator map projection. This was invented in mid 16th century. The person is a geography and a Mercator. What he invented is this up is a north, down is a south. Latitudes, longitudes are noted on the map. It preserves local directions and the shape. So it's really useful for navigation, and we use it until today. Pilots often use Mercator projection. Airliners use Mercator projection to make their flight planning. Pilots actually use a Mercator map projection for their flight. So what does mean for Mercator projection? What it is we always have a trouble to present three-dimensional object on a two-dimensional surface. So whether it is a piece of a paper or a computer screen, they are considered as a two-dimensional space. When we try to represent a three-dimensional Earth, we encounter a lot of challenges. So what we do is we sort of imagine, to put a cylinder over the globe. Then you have a flashlight or just a source of a light shining on that globe. And eventually the light is going to be on either side of a wall or maybe a huge piece of a paper. Then you flatten up and then you're going to have a sort of a representation. In the ancient time, these maps were calculated by sophisticated math equations. Today we use computer to just to choose a specify a map projection for a specific purpose. So this is the current map in Mercator map projection showing the Earth system by NASA's Earth Observatory. We definitely see 70% of Earth's surface is a water by world's oceans. 7 land masses representing all the major continents on this map as well. We do see some distortion for size between Greenland and Africa. So if you look at it here, this is Greenland, this is Africa. The size of both looks similar, but really in reality, Africa is 14 times larger. So we see the distortion. But as far as for pilots, because the local compass bearing is captured pretty well, so actually we still use it. And also it shows during the middle portion of the northern hemisphere, you see that's where the world's land masses are. Southern hemisphere, mostly water, a lot of blue, and the mid portion of the northern hemisphere, that's where probably the top 20 largest countries are located at, right? So if we try to look at a distribution of largest economic development in today, and actually that's where they are as well. Basically because that's where lands are, that's where people could get settled on. And the other thing is a distortion of a frozen land mass of Antarctica. If you look at the bottom here, so up to about 80 degrees south, a huge stretched out Antarctica. So that's a distortion as well. So for a flight, we usually have all the flights planned for a mid-latitudinal region of a northern hemisphere, right? So basically, it does serve the purpose pretty well. Now, here goes back to the 18th century, which I call it as a kind of a modern map making era. This is a quite famous map made by Henry Polham. The map is called A Plan of Boston in New England with its environs, which was made in 1775. Very detail-oriented. All the environmental attributes are portrayed on this map. And also we see surroundings of Boston. To some degree, this map is a precise geographical document. It also serves as a political tool because it captures the tension between the American colonies and Britain. This type of a map were very popular or common during the modern era. We called it as a semantic map. Particularly, this map is called isothermal chart. So thermal means temperature, iso means equal. So these lines are equal in temperature. Therefore, it shows a spatial distribution of the world's climates. So the world is a large place. According to a carbon climate classification system, there are just about 5 major climates. They are distributed according to latitudes. So you have equatorial latitudes referring to between 0 to 15 degrees north and south. That's your tropical climate. We call it as A climate. Then you have a B climate encompassing about latitudes 23.5 to 30 degrees in northern hemisphere and also southern hemisphere. That's your B climate. And that is where the world's climates, deserts are, okay? And then away from that B climate in both hemispheres, we have a C and a D encompassing the mid latitudes. So we are basically in that D climate, which is mostly influenced by polar air mass or continental originated air mass. All right, so this is fairly close to what we see today. A very powerful visual narrative of scientific information. So we see kind of a combination of art and science. This is a satellite world map, which is projected in orthographic map projection. And again, here we see 70% of Earth's surface is portrayed in blue. These dark purples are extraordinary or above normal sea surface temperature. Generally speaking, there's like an equator vaguely discernible on this map. We also see major 7 land masses here green represents vegetated land cover. We also see some distinctive features. For example, Andes Mountains, located on the west coast of South America. We also see tropical rainforest in Amazon, Congo River Basin, which is the second largest rainforest. Then we see some other green color here. That's Southeast Asia, but forests are rather fragmentedly located. Some forests in Asia, South Asia. We also see some vegetated land cover in Europe as well. So generally speaking, in the Arctic and Antarctic are relatively preserved, but the size may not be quite true. So it's very powerful visual representation of the physical environment at a global scale. During modern era or towards to about early 2000s, we see the pop-up of a digital mapping. Digital mapping refers to the use of a computer system, for example, geographic information system. I think the very first digital map appeared in 2003. That was made by earlier GIS software, and today we no longer use that software anymore. We use ArcGIS Pro, which has a lot more capability working with not only points, lines, polygons, but also we work with a lot of satellite imagery. The very last map I showed you, the distribution of land cover, that basically is the use of a geographic information system to best characterize the Earth's surface. You probably wonder what is the remote sensing. Remote sensing is a technique or approach we use to create kind of a imagery, and then we bring them into GIS. Then we can create maps to show comprehensive environment. Satellites are very common today. They're up above 30,000 feet above sea level, 30,000 in the orbits, right? So we have a lot of them, meteorological, natural resource monitoring. We have a lot of them. So they could provide up to date at a relatively short time. They also provide a lot of details because they use a lot of equations from magnetic spectrum. So basically we can process them, extracting a lot of useful information about the land cover. So quite efficient and also accurate. So it's a blended of approach with GIS. We can continuously monitoring and tracking what's going on. For example, wildfire in California, we basically use the combination of points, lines, polygons, and also satellite image to monitor the fire spread and how many fires at the same time. Therefore, we can decide how many firefighters should be deployed to where for how long. As I lured earlier, there are a lot of technology used for map making during modern time because the computer provides more opportunities for interactions and faster and a lot more efficient. So we see the use of Google Maps. They popped up on all kinds of devices, iPad, iPhone. Utility companies use iPad for their utility field work, often maybe some birds migration tracking, transportation roads planning, and repairing. So they are used commonly as we are entering into today's world. I see a lot of folks around me who use OpenStreetMap to schedule their local meetups, events, and also widely used in social media. One thing I found interesting today about map making is crowdsourcing. So it seems like a citizen science has widely used for data collection. We see much wider map coverage in the internet. See a lot of people involved with watershed protection and also like indoor-outdoor air pollution monitoring. It's just a great tool to have that internet-based computer mapping to engage community and also empower some disadvantaged group. So here what you're seeing is actually the application of a GIS for York County. This map particularly shows spatial distribution of a senior population. The darker color, there's a red, these are red polygons. They represent much higher percentage of a senior population. It's a static because I did a screenshot and I really want to take everybody to the website here so we can have a kind of the view of how that real world GIS portal works. So let me here see here if I can share my screen again. Let's see here. Give me a minute here. Okay. So can everybody see my screen that says York County Geographic Information System portal?
Yep.
Okay. Okay, great. So so York County Planning Commission is the creator of this website. So we see a quite democratization of a data into just the public domain today. So if I scroll the web page down, we can see applications here. You see York County Property Viewer, that a web application, comprehensive plan applications, general application, education application. So they basically, you know, they are already process some geographic data to make some maps to help people understanding what's going on. So this is what it's like. I have to click this agree to the above terms and the conditions. You can zoom in, zoom out. So interacting, you can pan, and I can zoom all the way into York City. Take a look at the shape of York City. How would you describe the shape of York City? What does it appear to be?
It appears as though it's following some pattern in the geography of the land. Could be roads, could be river, streams, rivers, but it seems to be following some geographic pattern.
Yes, absolutely, Larry. That's
In the chat, you had octopus and spider as a shape.
Oh, okay, okay, okay. Well, that's very good. That's very good. To me,
I like
it
the
looks like a
creativity.
right. To me, it looks like a crab. So Caduros Creek actually runs north-south, splitting York City into two. Larry is right. So basically, we have a 30 to the north, you know, and generally speaking, the city proper encompasses those major transportation thoroughfares. So you can actually zoom our way in, you know, to find out a property. Here is the search box. You can enter your address. Then you're going to have aerial view of your property. So, you know, for county assessment office, you know, they use this to monitor kind of a land use changes, you know, try to make sure and all the land use practices are on par with local zoning. So this is one application. Now, if I continue to scroll down, you're going to see a lot more thematic data that is available to general public. So you have a boundaries that encompass administration, then you have a transportation, you have a facility planning, recreation, land conservation, hydrology, environmental. So we do see a lot of data in public domain available for general citizens like you and I who could use a mapping to enhance our understanding. That's this one here. The next one I want to show you is this one here. I have to change, toggle back to here. Just bear with me for a minute here. So I'm back to my PowerPoint here. What you're seeing here is a screenshot of tropical cyclones from a NOAA National Hurricane Center. Let me take everybody to the real website. You can see the application of a web map making. So this is the website of a National Hurricane Center. You can zoom in, zoom out, which is done by Geographic Information System. And you can actually check other latitudinal region. And this is in Eastern Pacific. Is everybody seeing my screen or not? I think you are. Okay.
Yep.
Okay.
Looks good.
Okay. You also see Central Pacific. You can actually check for real time for 2-day graphical weather outlook, 7-day graphical tropical. So they give you all kinds of near real-time data and also information represented on the map. Since looks like we're okay with the time, Melanie, can I show the interactive map making platform to bring everybody kind of an interesting point of view of manipulating data that we have gathered from satellites from citizen scientists. Is that going to be okay, or?
Yeah, as long as it works on your end, it should work on
Okay.
ours.
All right, okay. Okay. So can everybody see my screen for this interactive mapping here?
Yes.
Okay, so here on earlier from the NOAA National Hurricane Center, we saw kind of an isolated 3 geographic areas: Atlantic, Pacific, and also the other region. But on this map, what you're seeing here is a lot of these. There's a little yellow circles, right? So I can actually zoom in to find out the particular hurricane event. Now, hurricane is the extreme weather phenomenon. It is the result of an abnormal atmospheric condition interacting with a hydrosphere. So on this one here, I think everybody probably knows this. That's a tropical storm, Francine, that just hit the Gulf states last Wednesday, I believe, right? And this one, if you click on the map, you actually get some pop-up information about Tropical Storm Beryl occurred a little bit earlier. So these kind of a mapping really enhance our understanding and helping for disaster relief planning and also deployment of natural disaster aids. So it's sort of, build upon those earlier maps, simple, just representing oceans and the continents. We even have quite comprehensive data, largely from satellites. So this one here is to show you historical hurricane events, a lot of them. So with these much of data, we can use the statistical modeling to predict where your next storm will most likely land, and we can make plans for evacuation, so on and so forth. So very powerful visualization narrative from a map making today. And down here, we have evacuation routes. If we overlay them, we can get a lot of uses in any event of a hurricane made a landfall. So just the sort of, on the screen to give you a sense of what map making today, what maps look like today. Let me toggle back to my PowerPoint here. National Interagency Fire Center California has a lot of fire, wildland fires. It seems like an increasing trend in other parts of the world. We're talking about Europe as well. So these kind of a computer-powered mapping platform provides nearly real-time information. I kept emphasizing near real time because we still cannot do real time. There are still some lags. We just cannot get concurrent. So what map making will be like for future? Now we're starting to see 3D and augmented reality mapping. For example, LiDAR has been used for creating maps for Pennsylvania. We're lucky to have a seamless coverage for entire Pennsylvania. I don't know if Jerry Jones showed you guys that LiDAR produced the maps. They really show underground structures. We're talking about near crust. I'm not a geologist, by the way. So LiDAR made maps really show those near lithosphere structures. For example, rock formation, how deep a water table might be, in the aquifer. So those type of things. So LiDAR becomes very important. We also see drones being used in creating maps. That you can do smaller areas with much more detailed mapping. Augmented reality mapping has been brought into GIS. We actually have a digital twins. It is an application city governments can create a digitized model of a real city. For example, Baltimore or Philadelphia would be able to be represented in that three-dimensional digital twins, and then planners can plan what their future land uses will take place at. As you have already come across, artificial intelligence and has come into our world very quickly. I anticipate AI and machine learning will automate a lot of map making processes. So to some degree, GIS will have to explore new frontiers because making maps will be gone because the involvement of AI, but they cannot replace human brains for analysis. We see more and more data, just so much data that we can use very large data sets for predictive mapping and analytics. So at last, I want to show this interesting map. The world is a cat. So you see the shape of all the continents together. It looks like a cat, right? And Australia or Oceania is like a ball, a toy played by the world. This is actually the digital creation, I think back to 2018. It's a kind of an interesting representation to some degree. Today, when I talk to students, I often say maps are made for the purpose of science and also art. So that's a quite kind of a remarkable way to put maps into context. So I want to conclude my presentation by stating these. History of maps really show our curiosity. We want to know more. We want to have new discoveries. Technology like a computer advances will only help us to understand the world around us more, with more detail, with more interesting things. So the journey of map making is far from over. We see a lot of geographic realities, not just the physical environment, but also a lot of social phenomena. For example, vulnerability of natural hazards by certain populations at a census tract level. So we see that kind of a scientific mapping to help us to to move society towards to a better world. I guess that's the way how I really want to put it in that way. Last but not least, I want to okay. So I want to introduce this book. It's called How to Lie with the Maps. It's in Amazon, pretty easy reading. When you have a chance, maybe you would not mind to read it, see how map makers like myself to create a maps, to communicate certain messages in intentional way. I remember I had to read this book 3 times when I was in grad school, and each time when I read it, I found some newer information, which is very intriguing. So with that, I'll just close that. Are there any questions for me?
Well, first and foremost, thank you so much for joining us this evening. That was terrific.
It's the end of the day, so I taught 5 classes today.
Oh no, and we just gave you more work to do. Well, we appreciate you being here with us after 5 classes today.
Oh, no problem at all. It's a pleasure. I'm glad I could do this. Many thanks to Jeri Jones, who invited me. And talking about the maps could take me more hours. I don't even feel tired. It's just
I had a question. Can you hear me?
yes, that right? Okay, yeah, I can hear
Yes.
you.
Back in the ones by Ptolemy, how did they plot those 10,000? How did they know how to plot places in those days?
That's from historical accounts, from books, literature. And then they plot them based upon latitude and longitude. So in today's world, we call it as a geocoding. So you go through historical literature books, maybe memoir, whatever, maybe essay, and then you go through them, you find out a place, and somehow you have to go through manual geolocation, georeferencing, and then plot them on this map, because this map, and you can tell they have a intricate latitudes, longitude. So 0 is equator at the middle, and then you have all the way up to 90 degrees to the north. So any places on the Earth's surface has a unique set of latitude and longitude. So with that, we can plot them on a map like this.
Thank you.
Yeah,
If I may ask a question?
absolutely, Larry.
Looking at maps like this and comparing them to today's maps, you realize how the accuracy of locating things has gotten so much better than, of course, through history, it's constantly improving. And if I'm not mistaken, I think I heard recently where a lot of these USGS geodetic markers are found now to be off by some manner of feet, because modern technology has refined the location of things to that degree.
Yes, absolutely, Larry. You're quite right. So the earlier time, for example, back to early 19th century, some French geographers were standing at the front of a map making. So they actually had to use total stations. So it's a manually involved. They have to put the total station on our surface conducting field survey. Consequentially, you're going to have some errors, right? And either equipment, physical equipment, maybe uneven surface where a total station was standing at. Today we have a GPS, right? We have a satellites, and at any given time, your phone would give you relatively accurate latitude and longitude, which is way much better than those earlier location reference done by total station. So yes, technology has been a great assistance in terms of geographic accuracy. Of course, today we are making maps beyond locational reference. We are making a lot more thematic maps. As I mentioned earlier, either in hurricane evacuation, or air pollution, even some lead mapping. Recently, I got involved with New York City doing some lead mitigation mapping. Yes, absolutely. We're seeing better accuracy, more and more close to reality. However, we cannot completely represent the reality on our maps, whether that is on piece of paper or on a computer screen.
Hi, Dr. Pomeroy. I have a question. Can you hear me?
Yes, I can hear
Yes,
you.
thank you. So, I was actually out hiking with some friends in Lancaster County this past weekend, and we were comparing the maps we're using, and I have a subscription to All Trails.
Mhm.
Which they do amazing, absolutely amazing topographical and, very extremely accurate maps. My friend didn't have All Trails, she had a Pokemon Go app,
Mm.
and, we actually got off the main trail and onto a deer path and couldn't find our way back up a very steep slope, and my All Trails didn't have the deer path listed, but her Pokemon Go app did. So I'm just curious, where do these apps tend to pull their mapping data from? Because when I went back and compared her Pokemon Go to, I still have GPS on my phone even when I'm out of service.
Mhm.
Her Pokemon Go app was just about as accurate as my phone's GPS, but less, but more, but my All Trails app was less accurate. So I'm just very curious how where they're pulling their data from for these apps.
Okay. All right. Good question. So for all trails, I do have that app myself for hiking. So all trails pull their data or maps from topo maps. So they are made by U.S. Geological Survey. So all trails, or sometimes we call them as digitized topographic maps. Uh, we probably have not update these topographic maps for certain geographic areas. That would be my explanation for why your All Trails maps um, did not have the same kind of information as your friend who has a Pokemon maps. As far as where Pokemon poster maps out from, I don't have a precise answer for that, but my kids play Pokemon all the time. I actually had to play with them before they left the home for colleges. So seems like they're pretty accurate, and I think they probably use a Google Map or OpenStreetMap as the input data source, because those ones they are updated by ESRI, which is Environmental System of a Resource Institute. That's the software developer for geographic information system software. So they do a lot of a field campaign and a validation. So data in that application and other sort of like a game, I think a lot of games, and they probably tend to use those as their input. Uh, and on the other hand, map, when we look at it, we tend to understand our world in this kind of a flat sort of environment. But we have to contextualize or place that place on the Earth's surface, which is curved, right? So Earth is really not flat, and we actually don't have a precise shape description about what Earth is, because Earth, was first understood as a round shape. Now we changed to spherical, and then we kind of observed a lot of highs and lows on our surface. So we scientists or cartographers came up with this best representational model, which is called a GOI. So it's a mathematical model representing this three-dimensional kind of object of Earth. We can do pretty good job. However, you're going to have some discrepancy. I think a current satellite system GPS probably gives you about 2 centimeters off where it's supposed to be. So when you're looking at a very localized area, you're going to have a slight accuracy off. But as far as precision, we have leaped forward to much greater accuracy today, especially with the help from satellites.
Oh, wow. Thank you. That was really informative. Yeah.
That was a good question. I hope I answered your question. I have to look it
Yeah.
up what data source Pokemon used.
Yeah. Thank
Somebody
you. It was very enlightening this weekend.
Very good.
somebody asked in the chat if there are any other map apps that you might recommend.
Let's see here. I do have a couple of them on my phone. So here I'm trying to pull it out. Has anyone heard about RockD? Did Jeri mention that to everybody here? It is app you can install, pull it, I think from a website to help you identify what specific rock formation for a geographic area within United States. And it used to be free because I've had it for 5 years. I don't know they charge it because I heard from some of my friends complaining about the charge for RockD. So if you go there, depending on where you are, RockD app will bring you a specific rock formation, what kind of a physiographic region. For example, if I do it now, it tells me where I am at, which is right at the center of York College. It tells me York College is located in the Hanover York Valley, which is a secondary physiographic region classified by U.S. Geological Survey. The most dominant rock type is a limestone and also dolomite. So that is kind of useful, I think, particularly for folks like you guys. Seems like you guys know a lot more about geology. That may be useful. I also have a couple of apps made by U.S. Census because I looked up demographic, kind of a socioeconomic information as I do some work, So those are free. You can go to your app store to pull them out, download them on your phone device. If you're on computer, there are all kinds of them. You can go to ArcGIS Online, which is a free mapping interface. You can use a lot of ready-to-use GIS data, either they're related to a physical geography, maybe related to current events. Some of the data available for example, gunshots in gun violence in the United States, and maybe educational attainment for Europe, because all of these organizations have a kind of a data available feed into ArcGIS Online. So that would be another option I would recommend. Similarly to ArcGIS Online, there's a place called QGIS. You can download on your computer. You can do all kinds of mapping. Whatever you want to map will be okay. What's nice about ArcGIS Online or QGIS, they give you like wizard steps. So they tell you, okay, the first step is to bring data. What kind of data sets should be brought into this software environment? And then they tell you next step what you need to do. So in a simple 4 or 5 steps, you can create a map for yourself. So I would say RockD for you guys on your phone, ArcGIS Online, or QGIS for computer-based recreational mapping.
Well, Dr. Pomeroy, thank you again so much for joining us this evening. We really appreciate it. I think you answered all of our main questions. If anyone thinks of any other questions later this evening or tomorrow, feel free to email Jeri, and we can always get those questions answered for you guys. But I think we are going to wrap it up for this evening. Like I said, thank you again for joining us. Apologize that you had to teach 5 other classes today and ended with us.
No problem.
But we
It's a
appreciate you
joy.
being here, and it was very, very interesting.
All right. Well, thank you very much, everyone. Thank you for having me.
Alrighty, we will see everyone in 2 weeks for our nature trivia night. Hopefully we will see you there. If there are any questions in the meantime, like I said, please feel free to email Jeri. We can get those questions answered for you. But in the meantime, enjoy this beautiful fall weather, and we will see you in the beginning of October. All right, everyone, have a
Good
great
night,
evening.
everyone.
Bye, thank you.